This is presented by HVAC to Home Performance, HVAC ADHD with receipts. I'm Jeremy Begley.
Hey guys, welcome back. I want to talk to you really quick about a very important document in your design process, or if you're a contractor receiving a design for a high performance home, custom high performance home especially, then you should be asking for the commissioning plan. How do you know what that system is supposed to do, how it's supposed to operate without some kind of instructions telling you what the intent of the design was? I also have wrapped into this particular document a submittal review. Oftentimes in these high performance designs, we get contractors that once they go out to bid, once they go into what's called construction administration, which is the period after the design is done but before that the project is being built, when contractors are getting hired, equipment's being purchased, things like that, there's often a lot of changes that people want to make because they either want to change it to their own brand of equipment that they sell, or they don't like your ventilation strategy and they want to do it a different way, or the controls are different than what they're used to. All these different things are changes that may or may not want to be made by contractors or builders. So there is a formal process known as construction administration. In the commercial world, you don't see it as much unless it's really a system wiring diagram and an alternate wiring diagram if they're not going to use Haven, as we recommend in this round of documentation. And then lastly, the commissioning checklist. In our submittal review, so as part of the submittal review, they asked for two things. They wanted to change the thermostat and they wanted to change the second floor return duct configuration. We totally denied the request to change the thermostat. They wanted to change from Mitsubishi proprietary controls to a Honeywell T10 Pro thermostat. Just not going to do it, guys. Right here we tell them why. We say specifically the T10 lacked native C105 integration. That's the Mitsubishi's native integration, and does not support, and this is the important part, variable speed inverter modulation, resulting in staged on-off behavior. It's totally changing that to that particular stat totally defeats the purpose, or one of the major purposes, of choosing this system for a design. So that cannot happen. We suggest them an alternative strategy, which is basically our original strategy with a wall-mounted stat added in, if that's something they want, to control the system and not have to go into, because the way these things work is either you have three different ways and three different kinds of control, really. There's direct control by the installing contractor, who can hook some kind of computer right into the interface board of the air handler or the outdoor unit and set the system up the way it needs to be set up, and also go into test mode. Bunch of different things you can do that way. The other way to do that part of it and to sort of control functionality like temperature and stuff like that is to have a wall controller that will allow the contractor to get into the back end of it and make all those changes, and then the homeowner can use the front end to control the system as well. It was suggested to us one time that the best way, and we really like this particular setup, is to mount that wall controller in the furnace room or in the utility room where the system's at, allow that to be the main controller for the system that controls the logic and everything like that. In the common area, with the advent of Bluetooth and wireless and apps and all that, we would have a regular, what would start out as a regular tablet. It would either get mounted on the wall, or there's nice little counter stands you can buy that create nice little stands for these tablets, and that is where the Comfort app from Mitsubishi would be up at all times, and they would have full control over their system from there, full access to the Kumo Cloud, which controls a lot of different things. You control your DHU from there, you control your system up and down, you can program it, you can do a bunch of different stuff. So that is the way that we would like for the homeowners to control it most of the time, and leave the main control in the utility room. Return duct configuration. Original design called for central hallway returns with jumper ducts for the bedrooms. That was our design. There's 6 bedrooms up there. It's a long return trunk. We didn't want to put return in every room. It's a lot of static pressure to deal with. If we're perfectly fine with jumper ducts and central hallway return. These guys, the contractors, they want room-to-room return. So, okay, either pay us to, basically what this says here, it says they may upsize. This may require resizing of the return truck and should be verified in the field or via updated duct design calculations. We say it like that because you have to pay us to update the duct design that we already turned in and got paid for. So if you want to change that, then either A, pay us or make the changes and have us approve them, or B, do the changes and verify they work or pay the price afterwards. Like that is that's the choices that the contractor has there for that change. This is a submittal review table. We always review this, or we always include this. These are the things that were submitted for review. This is what we specified. This is what they wanted to use. Most of it's pretty tit for tat, except for these couple items here in the beginning that are called out and that we already talked about. Here's the commissioning plan narrative. So this right here is basically what it sounds like. It is a written paragraph or two explaining how the system works, laying out the whole entire system and how it's going to be commissioned. I'm not going to read you this whole thing, but a few of the highlights. This is commission. This is, or I'm sorry, we do highly suggest they use the TrueFlow grid and Measure Quick during the commissioning process. We write it into our commissioning protocol. There's no way to like make them use that, but we don't stand on the commissioning the same way we would if we don't have those documents from Measure Quick that are time stamped and dated and tell us that the stuff was done the way that they claim it was done. We really like to see that, and you'll see some of that written into our language here. This is section 2.2, also very important, our electric heat lockout and enablement logic document. This tells us tells the contractor where they need to lock the system out at for the optimal performance. What we mean by that is if this is a system, it's in a very cold climate, okay, this is in Minnesota, ACA says design to -13, the state makes us design to -15 in Merrimack where this system is at. Or I'm sorry, I said Minnesota, it's Wisconsin. I don't know if I said Minnesota, but I meant Wisconsin, Merrimack, Wisconsin. Very cold climate, okay? So we know that what we have designed, if implemented the way that we design it, will service this load all from the we've done ballast point calculations, we've done heating degree day calculations, we've done a bunch of different calculations that leave us assured that 99, and I'm saying a literal percentage here, 98 to 99% of the time, this system is going to be, or the system load, heating load, even in the negative temperatures, is going to be fully handled by the heat pump. So we spell that out in a little bit here. You'll see a little bit of that. But the main point to get from here is enable electric heat only when outdoor temperature drops below 5 degrees and one of the following is true. Stage 1, heating demands exceeds 15 continuous minutes without satisfying, or return air temperature falls 2 degrees or more below the thermostatic set point. And then this should be verified using the manufacturer specified field setup tool when it's being set up. And this CN24 is the terminal. It needs to be wired and staged to make sure that this is working the way that it should. Okay, and this is all from Mitsubishi documentation. It's pulled straight out of there. Section 2.3 is our airflow commissioning instructions, another important document. So on these systems, it's interesting. So you're going to see that we say each configured for approximately 600 CFM of total airflow design. Each air handler must be tested and verified to meet or exceed 90% of design airflow using one of the methods below. TrueFlow grid is our preferred methodology. But here's the thing. We put in here, so these numbers here, minimum acceptable airflow, these are actually our design airflow numbers. But the reason that it is written like this as this amount of airflow needs to go through here, and this is our minimum, and our target airflow is 400 to 600 CFM per zone. That is because these are airflow at design, okay? But these systems, a few things happen. One, they're 18,000 BTU systems. They're completely variable, so they have the ability to ramp all the way up to 600 CFM if they see a need to do that. 600 CFM and full capacity. Oftentimes they will do that. Even for a brief moment, they'll ramp up to 600 CFM and they'll make sure that they'll satisfy the load, then they modulate back down to where they need to be and keep the load satisfied. That's how these things work. So you have to be able to handle that airflow. That's not necessarily your design airflow, but you have to be able to handle that airflow in the duct system. Another thing is, like, these things can put out 21,000 BTUs of heat, okay? They're 18,000 BTU pieces of equipment. If they need to put out max heat, they need max airflow. So you have to facilitate that airflow. So that these ducts have to be designed to facilitate max airflow, even though the system probably won't always definitely will not always operate that way. It'll usually operate at something much less. But remember, better oversize them than undersize them. All right, when it comes to ductwork, not systems, ductwork. All right, and then you got your static pressure profiling requirements. We're pretty specific about this. We want we want a static profile taken of each system. That's part of commissioning, and we want all this information. Then we have our dehumidifier airflow verification. That's set up separately based on the information from Santa Fe. And again, we sort of give a range on that because you don't know exactly where this is going to land at. And then we have our measure quick commissioning and documentation requirements here. And then we get into our ventilation control upgrade recommendation. Now this is something that we put in here because when we first started on this project, we weren't that familiar with Haven, and we didn't really understand how it controlled systems. Since then we've become really familiar. This has been a 3-year project, so we've learned a lot in 3 years. Okay, so some things change. So we're like, hey guys, there's a better way to do this now. Here's how we think you should do it now. You don't have to because it wasn't part of the design, but we do feel like in a cold climate, on-demand ventilation is the very best thing you can get. At a minimum, you want to do intermittent ventilation. You definitely don't want to be doing continuous ventilation in a place that gets freezing cold. That's just a big no-no. So you're either going to do intermittent ventilation strategy, which we did here. You'll see, so how this is set up, let's just get into this. How this is set up here is, right now, it's your typical setup with a Santa Fe dehumidifier with their smart air power damper. We had originally specified the Brone, but it's Santa Fe now has the Brone branded as a smart air and integrated with their system. You got to buy it separately, but it integrates directly with their system, so we're recommending using that brand because we are using Santa Fe, and it's available now. And that system, and then we're using Kumo Station to hook the dehumidification piece of the Santa Fe dehumidifier directly into the logic of the Mitsubishi system, so it can operate in conjunction with the Mitsubishi system. And then we break down the control benefits, why we think we should do this, and an implementation summary, how they can implement it. And then we give an alternative. We give a ventilation runtime schedule, and then the intermittent ventilation strategy that can either be set up. We even say without Haven, runtime control should be programmed directly through dampers, built-in timer, or manual relay cycle. Okay. And then finally, we have the system wiring diagrams here, and we show it with no Haven just in case that's what they're doing. And then we have the commissioning checklist. So there you have it. That is the a nice little 15-minute review of a very important document. The commissioning plan should come with every one of your high-performance designs, and also there should be some kind of submittal process where you make sure that any substitution still will operate your design as it is intended. That's it, guys. Thanks for joining me. We'll see you next time.